Hello, students. Let's read the problem. And it says, Nathan has a collection of soccer and baseball cards. He has 120 cards. There are 6 soccer cards for every 54 baseball cards. Which of the following graph shows the same unit rate? Okay, so let's see. Well, we know that Nathan has his collection and he's got 2 types of cards, right? The first one is what? Well, it says that he has 6 that are soccer cards, right? And for every 6 that are soccer cards, he's going to have 54 that are baseball. Now, it doesn't mean that he only has 6 soccer cards, okay? It just means that if, for example, if he was to get all the cards that he's got and he separates them and he says, you know what? For every 6 that are soccer cards, I can compare that to 54 baseball cards. Another 6 soccer cards, another 54 baseball cards. That's what it means by these kind of comparisons, okay? It does say something about the total cards, but I don't think that's too relevant because they're not asking us that type of question. And at the end it says, which of the following shows the same unit rate? So unit rate means like 1, right? Yes, it means like 1. Remember Spanish uno? All right. Okay, let's go on to the comparison here. So now, if you look at the labels that are given to you, now again, in this graph, I only see the X having numbers like 1, 2, 3, 4, and 5. And on the Y, I see 9, 18, 27, and so on. So what we're going to do is, we're going to say the Y, the comparison of the Y and the X, which is change of the Y over the change of the X. I'm going to give those X and Y depending on which number has the largest or the smallest one, right? For example, 6 is a small number, so I'm going to leave it for X. 54 is kind of like a larger number, so I'm going to write it as a Y. So I'm going to write down my comparison as 54 over 6. Okay, now remember that 54 is what? 54 is your baseball cards, and 6 is the soccer cards. Okay, so what I want to do next is, well, I'm going to write it down as an ordered pair, as an X and a Y, in case that you feel more comfortable finding that ordered pair like this instead of the 54 and the 6 and so on. So my X is going to be 6. My Y is 54. But notice how the highest Y value that I see on the graphs is 45. So that point or that order pair is not going to help us. The reason why we get it though is because this is going to help us to simplify. Okay? So if I simplify, remember, the more common or the more equivalent ratios that I find, the better for me. So I am not going to just divide right away by the largest common factor. I'm going to divide by something that they both have in common, which is 2. And 54 divided by 2 gives me a 27. And 6 divided by 2 is a 3. So what does that mean? It means that if you were to get a smaller number of cards, now we're saying, oh, you mean if I have 27 baseball cards, I should be able to have another 3 soccer cards, like next to each other, right? And I can get another pile of 27 baseball cards, and there should be another 3 soccer cards that I can kind of match with that. So that's why we said that these are equivalent, okay? So 54 and 27 over 3 are equivalent ratios, okay? Let's see if I can find another one. What number can divide 27 and 3? Well, both of them can be divided by 3. And 27 divided by 3 is 9. And 3 divided by 3 is 1. Okay? So now this is my other comparison. Okay? We can write down those as an order pair right below the 6 and the 54. So right below the 6 is going to be the x value. Remember, this is your change of the y over the change of the x. So x is on the denominator. So my second point will be 3, comma 27. And the next point will be, or order pair will be 1 and 9. Okay? So let's go to the graphs and see what can we find. So I'm going to start with the smallest one that I got, which is a 1 and a 9. 1 is x, 9 is y, remember? So I'm going to go to 1, which is right here. And then I'm going to find 9 on the side. And I'm going to see the point where these two intersect. That looks exactly on the line, right? Well, let's check the second point. Maybe it was just the first one. 3 and 27. This is 3 and this is 27. Go up on 3, go across on 7, and that point is again on the line. Awesome. Okay? Do I have any other point that I can compare? Not really, but you guys can find another equivalent ratio if you guys write down that the one that we found last, which is 9 over 1. If you multiply by 2, remember, you can divide or you can multiply to find equivalent ratio. So this will be 18 and 2. So if I want to find that one on my graph, 18 is y, remember? And 2 will be x. So 18, it's on the y, and 2 is on the x. And yes, the point I can see it right there. So it looks like A, it's pretty good. What about if we check the rest? Let's go to letter B. So I'm looking for 1 and 9. Well, the point should be here. It's a little bit off, right? What about if we check 3 and 27? This is 3, 27 is up here. Look at how much it actually went off now. A lot, right? So B cannot be an answer. How about C? Let's check 1 on X and 9 on Y. This is where the point, the two intersect, right? That's not right. That's not correct. Let's go to the 3. It's here. Just so that you can check that this will be way off. So these are where the location of the point will be, and that's not correct. So C is not right. What about D? Okay, so we're gonna do the same thing. This is 1 and 9, and 1 and 9 works. Don't stop there though. Check the second point, 3 and 27. So this is my 3, and this is my 27. So I'm gonna go across, and I'm gonna go up on 3. This is the location where the 2 points intersected. Is that even close to the line? No, it's not, right? So what's going to be my answer for this one? The answer should be letter A. Very good.